So let's take one example of a projector. The backbone these days of projecting into a waveguide is CMOS, liquid crystal on silicon. But the next generation, let's see, the things that emerging is the micro LED. So let's compare the two. So we talk about here, this is like how LCoS would look like, but I unfolded this for simplicity. So you have a source of light, which is colors, LEDs, and then these colors cause what's called homogenizer, means the output from this homogenizer is a uniform, all the colors emerging from this section. Now this section propagates the optics, collimate the light onto the liquid crystal, and this liquid crystal is collimated into this aperture, and this is the aperture I showed before. This is schematically, which is the entrance to the waveguide. So entering the waveguide, we have the light that comes from here, and for efficiency, if you properly design the optics, this plane of homogenized beam should be imaged directly here. So each beam that was collected from this section enters the waveguide. That enables the LCoS system to be efficient. It's losing half the power because it needs to be polarized, but basically it's a good, efficient way of coupling light into the waveguide. Now let's look at micro LED for comparison. It's actually the last section only. So you have light coming from the micro LED and then collimated into the waveguide. But here we don't have this pupil imaging approach and just light that's scattered Lambertian or any other distribution. Some of it is collected into the waveguide. So we have much more loss when we look at micro LED when we try to couple it into a waveguide. The other thing that we have to take, for example, here since the light is more collimated into the waveguide, there's less scattering from the optomechanics around. In micro LED, we should take that into account. The light goes everywhere, and that creates a degradation may create degradation in contrast.